Now let's take a look at compound interest. So we have the formula A equals P times 1 plus R over N, all raised to the N times T. So P is our principal or our initial amount. R is the annual rate as a decimal. N is compounded N times per year. So we're going to see the words, it's compounded monthly, it's compounded quarterly, it's compounded daily, and so that is what N represents. T is the time in years. So compound interest. Now, a part of that is, so we're gaining interest on money you invest, and so we're looking at an exponential growth model, but it's a little bit changed because now it's compounded a certain number of times per year. So we're thinking of our formula, y equals a times 1 plus r raised to the t. So notice it's very similar to this. The only difference is now we have the words that it's compounded a certain amount of times per year. We have the n here in the denominator and then n times t. Okay, so it's very, very close. So here is an example. We're going to use this formula. You deposit $9,000 in an account that pays 1.46% annual interest. We want to find the balance after 3 years when the interest is compounded quarterly. So quarterly, that's 4 times in a year. So write interest compounded or quarterly, and then the balance, we need to find the balance after 3 years. So let's identify what we know. We know that the principal or the initial amount is $9,000. Okay, so that's what we deposit. The R is it pays 1.46%. So we have to change that to a decimal. And then so we move the decimal place over to the left or divide by 100. We would get 0.0146 as R. Then our compounded quarterly is N. N equals 4. So first let's write the equation, plugging it into that formula. So A equals 9,000 times 1 plus R, which is 0.0146, over N, which is 4, raised to the 4, so that's the N, and then time is going to be 3 years, so we have to write that. So T equals 3, and so 4 times 3. So now we have to plug this all into our calculator and solve. So it just depends on what kind of calculator that you have. You just have to insert enough parentheses in there. But what we would do first is it's order of operations. So if you have like just a general scientific calculator, then I would do 0.0146 divided by 4 plus 1 and then equals. And then raise it to the 4 times 3 is 12, so raise it to the 12th power. Then last, multiply by the 9,000, right? So think about how you would do it by hand. That's one way to do it by entering it into a calculator. So again, start with the 0.0146 divided by 4, and then equals, add 1. You could do equals again, raise it to the 12th, and then times 9,000. Now when you do that, the amount that you should get would be 9,402. And you have to round, so 0.21, okay, so it's money, so think about, so two decimal places. So after 3 years. So just remembering when you round, if you're going to round to 2 decimal places, the number after the 1, if you plugged it in your calculator correctly, would have been 210. So remember, you look at, so if you're rounding to 2 decimal places, you look one more past it. And then if it's 5 and above, you round up. If it's 4 and below, you leave it as is. So this is less than 5, so therefore it is just 21. Okay. So try this example here. You deposit $8,600 in an account that pays 1.32% annual interest. Find the balance after 4 years when the interest is compounded quarterly. So the big thing is being able to write the formula first, write the model. So this is the big piece that I will be looking for. And then after that, try plugging it in your calculator. So pause the video and try this out. To try this out, the principal is 8,600. The rate is 0.0132 as a decimal. It's compounded quarterly, so that's the same. It's 4. And then time is also 4, so time after 4 years. So this is what your model should look like. Then when you plug it into the calculator, you should get 9065.493, and it keeps on going. So you just look at the 3. 3 is less than 5, so then it just stays as 49. Okay, 9065.49, and then after 4 years. Now, if you see the word daily, for example, daily, that's going to be, let's just say 365. Okay, so that would be the N. So when you see that for the homework, that's what daily means. And then if it says biannually, so that's 2 times a year, so N would be 2. So just kind of things to look out for. So here is the homework, 1 through 10. Now, just to kind of help you out, I'll do the odds here, just if you're not sure how to do these problems. So if you're given 2 to the x, evaluate for when x is -2 and x is 3. So all you're going to do is you're going to plug in the value that they give you and then into the function. So for example, we have 2 raised to the -2, right? You're just substituting. Now remember, this is great because it's a review from last chapter. So 2 to the -2, so when you have a negative exponent, it means it flips to the other side of the fraction bar, and now it's a positive exponent. And then so 1 over 2 squared is 1 over 4. Then x equals 3, so we're going to do 2 to the 3rd power. 2 to the 3rd power is 2 times 2 times 2, so that is just 8. So that's very similar for number 2. Number 3, we have 8 times 3 to the x. So we're just going to evaluate when x is 2, so we're going to plug in 2 for our x. So we're looking at 8 times 3 squared. So order of operations, you have to do exponents first. So 8 times 3 is 9, and 8 times 9 is 72. Now, number 5, we have 5 plus 3 to the x. So 5 plus 3, and x is to the 4th power here. So 3 to the 4th, remember that's 3 times 3 times 3 times 3, or I like to think about it as 9 times 9. So 3 to the 4th power is just 81. So we're looking at 5 plus 81, so this is 86. Then to kind of help you out with number 7 and 8 here is remember once you figure out what you are working with, you need to find the rate. So especially for number 7, for example, here, you're going to set 0.715. So this is going to be, you have to figure out if it's growth or decay. You set that equal to the equation before. So what you will look at is, I don't have the work here, but look at example 2. Okay, so number 7 is like example 2, number 8 is like example 3, and then number 9 and 10 is just kind of like the last examples here, number 5. Okay, in another video, I'll talk about rewriting an exponential function, just kind of if you're interested in knowing how to do those problems.